Okay, I'll go over the Chanclas NFT machine. This is just a walkthrough of everything that's done. Um, so in the previous video, we did the API that basically we can connect to our PC. We can define the contract address, load the Chanclas API, and we can return basically metadata for a particular token only if it was mint. This way we prevent data mining for like we prevent someone trying to guess or brute force anything. It's the same thing for images. We can serve images too from the directory. This endpoint is also used to generate. So if it was mint but it's not generated for both of these, for the metadata or for the images, the metadata and the images are generated. So this is the API. So yeah, we get the endpoint for the image by token ID. Same thing for metadata. Then also the rarities that was we coded that together. Each part of NFT have different images with different rarities based on the period. The output of NFT of metadata looks like that, a description, the external URL, which is the ID, same thing with the images, the name and some attribute, which are basically the name of the category of the layer and the title of it. And this is what it looked like randomly generated. Of course, some don't have ads, some don't have eyes. There is some exception too. Everything was explained in the generate file. Basically, we have all the directories. We can load rarities by period. We can generate images giving a token ID, the period ID, because different period have different rarities in the JSON file. And we also provide the NFT seed that is generated on chain, and the output directory, it's always the same. So the function randomizing is from randomizer. The metadata is created here, but here is a simple random seed. This is going to be changed in production. This way we can let's say load from the environment the the way the randomness that is off chain to generate the layers and the graphic representation as well of the rarities. We can open source all the code, but keep just one secret seed that's going to be affecting that randomizing process. This way, we can prove that the code is not like backdoor and we cannot cheat it. The only thing that's missing is a seed that could be released in the future when there is no more minting. So, yeah, the seed is the only thing that's going to be missing for someone to generate the same result for that. You can see here the metadata. We are also formatting named. We can remove like the extension and some numbers, some special character to generate the metadata. The toe guard are the same on the base here. We're adding everything to the metadata. Regular layer because these are just together. We can also handle exception. There is a percentage. There is a possibility that at or eyewear are empty. This way, these are not added to the metadata nor the layer. And if the astronaut is in at, sorry, astronaut is glass or at, I'm not sure. Yeah, so if astronaut bypass was, wait, I'm confused. Huh? They're supposed to have a bypass for that. That's weird. I'll check in the code because there is astronauts should not be paired together with astronaut is at, so you cannot put glasses. There is something like that. I think it was removed for whatever reason. I'll just assure myself that it's still in the code. But yeah, so that's the two part. There is the API that serve metadata and images, generate, which is basically actually randomizer could be the function randomize could be in the same file. Initially randomizer was not public in the Git, but I added it. But we could suppose that here this part of the randomization would be outside of the Git. That's basically the only part. Um, if we go out of the backend and we go in the Solidity part, which is the smart contract, I'll just close a bunch of stuff and I'll just add note to myself, be sure astronaut exception and merge randomizing and generate. So the smart contract, this is the ERC 721. It's using access control and of course ERC 721. There is a access control minter role. Current token ID is stored in that contract. Also, the base token URI is I don't remember the name. How you say that? Overrided. Sorry. There is a token data structure here just to hold seed and period. Maybe we could optimize that with using a mapping instead of structure like this, like a seed and period. I'll check if it's more economic in terms of gas. So the constructor is the function that's created, that's called in deployment. You give a name, a symbol as the ERC 721 contract, but you also set an initial base URI and the address of the minter that's going to have the role to be able to mint. There is also the admin that is automatically the message sender. That can change role. The admin can change role. And we set the base token URI here. That is going to be the base of everything. And it's just the NFT ID that's going to be append at the end. So it can work with the API here. So let's say we run this on a domain. Here it's going to be localhost port 3000. But basically this is the token URI endpoint that we're going to fetch metadata and images. So the function that is mint, only the minter can call it. It takes an address for the destination and the period ID. The period ID is used, the current token ID is starting at 0. We get it here. We generate a seed. This is not truly random. Someone can guess what is going to be the next seed because it's only using block timestamp. Because, you know, let's say we are at 100 token in first period. We can generate a bunch of seed, and that's why the API should not be brute forced. So that's why if the token is not minted, if the token ID does not exist, like it's not going to work. I'll assure myself to compare always check if token ID match its seed if it's existing. I just want to be sure nobody can brute force the API and generate a bunch of images without paying actually. So this generate a seed, random seed. I'll show you what it looks like. This is not random, but that's why we use off-chain random in the randomizer function. The token data is stored, the seed and the period ID, and we call the internal mint from ERC 721 to the destination, and with the token ID, we increment it and we emit the event. This is just a simple caller to get the data, which is just the seed and the period ID. Kind of useless, or I'm probably going to remove, like I'm going to clean everything and just keep the minimum and try to optimize gas as well. Admin can change the token URI. So in the future, if there is no more minting, we generated all the images and the metadata. We could migrate everything once to IPFS, change the base URI to IPFS, and we're good. Just override to call base URI here too. and just uh, I don't know why the event is here. Usually it's on top, but not the end of the world. I'll change that too. So this is the ERC 721. Very simple, very basic. The ICO is the minter. It's going to be the contract that's going to be authorized to mint. It also uses access control. There is an admin here. I don't remember why the admin is set here. I think it's for sending the money to it. Yeah, I'll show you after. There is a structure of period. They stop a period end at a time. There is a maximum supply for a period. There is a price, and there is the actual mint count. There is the current period that we are in. There is an array of all the period. There is the token address of USDC, the interface here, ERC20, and we also load the NFT of Chanclas itself. We could use the ERC721 to it would work. That might what we're gonna do. There is also an event that is minted here. It's kind of confusing. I might rename it here or just like make buy something like that. But basically, the mint here is the destination, the token ID, the period ID, and the seed. Here we have the buyer, the token ID, the period, and the price because the seed is not in that contract. The constructor, again, is when we deploy the contract, the admin, USDC address, the Chanclas address, and period data. We grant the role of the admin to the caller again. Yeah. We load the ERC720 at the USDC data. We load the NFT contracts in here, and we initialize the period. We set the period. We just be sure that there is period that are given. I'll show you in the test unit what it looked like. The function mint here could be buy. I'll change the mint here for buy. We load the current period. We require that the period is not ended in time. We require that the minted count is under the supply that was given. Actually, max supply, that should be equal, I think. Smaller or equal. I'm not sure though. We get the price. We transfer USDC from the buyer to admin directly. That could be changed too, of course. We could accumulate USDC in that ICO's contract and do something at the end. We are minting in the NFT contract, which is Chanclas. We are minting to the destination, the person that buy, and we also pass the current period ID here. We increase the minted count on that period, and if it's maximum supply, if it's reached for that period, we gonna we add one to current period, so it's gonna be next period. But if it's not, the period gonna stay the same, which means this condition will fail because the max supply gonna be reached for that period. This was a basic color. I'm not sure. Again, it's like in the other contract. I will probably remove some stuff. But yeah. So the test unit, we load all the contracts. We deploy a fake ERC20 token to mimic the USDC. We give $100. We deploy Chanclas. As you can see, we get the name, the symbol, the URE, the token URI, the initial, don't forget we can change it, and we pass the admin here as the backend, which is the minter role. This is a period. It's a Unix timestamp plus 3,600 seconds, the maximum that can be mint, the price, one token. I'm gonna need to check that too because right now it's using the default ERC20, but basically USDC is like 9 decimal, I think, or 8. So just to be sure that is perfectly implemented. So we're deploying Chanclas ICO. We pass the admin, the USDC token, the NFT token, the initial periods array, uh, and we grant the minter role, which I think is not needed. I'm confused. API. Sorry. The minter role is given in the ICO, in the constructor. Sorry, so it's not needed. We don't need to do this part. It already have the role, I'm pretty sure. So we assert that the first period is over 0 because 0 is the default value. Um, yeah, so the first token is 0. So we mint 10 token. We get the price for that period. It's one token that we set. The user need to approve the token. This can be in the user interface, user experience, UX, but this need to be done by the user. We approve one token. We call the mint function from the ICO, and we can see that the token, the ID is going to be minted, and you'll see. Then at some point, we expect the next period to be 1 because after 0 is 1. Then we can mint up to 20 here. Same thing, different price. And then at some point, the current period max supply should be reached. The period should also be 2, which is invalid. It's not a valid period. I just tried. I'm pretty sure the test unit is not going to work because I just changed something in ICO, but we'll see. Oh, so the role is actually needed. Huh? Minter role from admin. That's confusing. No. Chanclas ICO. Wait one moment. We deployed Chanclas. Oh, the admin here. I get it. We need to deploy the contract before, but I was passing the minter as an argument in the constructor. So basically, we're gonna remove here, and since the default creator have the admin, we can then add the proper role manually calling the grant role function. Not the end of the world. Current max supply reach after period exhausted. Okay, so what I change, I think now is affecting um, current max supply reach Chanclas because the 30, sorry, 30 19. Wait, it's 89 989. Okay, should fail due to max supply, max reach. Yeah, so it's good because in total we should have, but actually it's not good. Wait, yeah, max supply here. It should indeed be under. Uh, Limited count. It's not gonna be under. Yeah, because it need to be all the time over. So the period is not gonna. If period minted count is equal at max supply. Okay. Just redo that. This was the original code. So we see that the tests are passing. It's deploying all the contract, and the token 0 in period 0 up to 9. That's 10 NFT as we set in the original period here. Then from 10 to 29, it's all 1, period 1. But so, but there is something wrong in that. There is only 19 that is minted. Uh, I mean, 29, 19, that's 10. Yeah, there's only 29. That's wrong. But no, because there is 30 NFT in total because the 0 count as 1, 2. Yeah, yeah, that's good. Yeah. So that means each time the user sent funds in USDC, it went to the admin, and the contract minted and respected all the period data too. So yeah, I showed you in the past videos too how the backend was working, how it's generate, and also how the API work. But sorry, I could add some data. Chanclas. Could I? Yeah. Let me just do something here real quick. I'll just show you what the NFT look like. I'm not sure I'm gonna see it that easy, but you're gonna see the seed. Yep. Args. I'm not sure if it's the proper one. Price, token ID. No, sorry, it must be the second one. Just want you to see the seed. Red ID price. Whoop. Oh, that should be the. That's all. Lux 01. Am I stupid? Okay, yeah, I'm very stupid. But yeah, the point is the seed is stored indeed in the smart contract with the period ID so they can be used. Actually, they can be served to the API when someone, let's say, the first time you mint it, uh, as soon there is a request made to the endpoint, it's gonna generate it let's say it could be OpenSea trying to fetch the image. If it's minted, um, it it will generate the proper metadata and the proper image that go with that period and that image. Look, I'll show you. I'll show you real quick. Just run that real quick. Oh. Just going to moment. Let me just mask this for now because I don't want to deploy the contract right now. We're just gonna add the bypass because I showed it in my last video. That is indeed working pair there. But we need that. We need the contract to get the token, the period ID. Okay, never mind. I'll do. Hello. Okay. We're gonna connect to the local network, which is running in the console. We're gonna deploy it on the Chanclas. Doesn't matter. That will be the token host. 2000. And we're gonna set ourselves as the minter. You can see the token is deployed there. Same address here. So I'm gonna mint myself for the period 1. So of course that will cost money, but I'm just making it free because I'm the minter. Period ID, me myself, and you can see the two events here minted with the seed here. The ID is 1, the 0 token ID, but the ID is 1 of the period. And you can see the other mint function. I think it's twice there. But yeah, the seed is there. Oh no, the other one is not because we're not in the ICO. But that's the seed. That's random stuff from on-chain, which is the block timestamp, the token ID, and the period ID. And that's going to be mixed with off-chain secret. We can get the token URL. It's going to be that, of course. So what we want to see is if I go to localhost NFT, let's say 2, oops, What is the endpoint? No, it's right there. It's right there. So the token ID 2 is not minted, nor the 1. But if I go to 0, generate images take 4, but 5 was given. That's weird. 4. Generate images. Oh, that's odd. No such file. Chanclas backend layer background blue. Don't tell me there is no. Ah, that's a typo, brother. That's a typo in the images, I'm sure. No way. What? That's so weird. All the layers are gone. What? That's so weird. Okay. Ah, no way. What that could be? But this is not normal. Oh, I think I removed from the Git. If I go there, Chanclas. Come on. Chanclas backend layers. Yeah, that's weird. That means I removed it. Mm, 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 Chanclas. That's not good. Backend, but no, yeah, exactly. It's not. It was at some point on the Git. The layers. Because I know there is some file that I renamed to match. Maybe not. No, I don't think I removed. I'm not sure. Okay, let's go get it anyway. That's dumb. I'm so confused on why all the images are gone. Hopefully we don't get an error. I mean, we're gonna solve it. Error. Let's see. That's odd. let's go back. Let's go. So we got the metadata. Of course, the external URL is what is hard coded in the API, but this is valid metadata per OpenSea. And if we got the image here, we should see it. Nice. So this is what I got with the seed. Storing the seed in the metadata would be very nice, by the way. But if I go here and I get so using that seed and the period ID with the rarities that are provided in the rarities here, which are they are all eagle by the way. Equal. But yeah, this is the output that we get images wise and metadata wise. So anyone with the same code with the secret generation of the randomizing, which is right now not secret because it's just random the seed, and its seed gonna be able to uh, have the same image. So the goal is for already minted tokens if someone provide a seed and it's match the NFT that is requested, it's gonna be the same image.